Hey DLI kids, this video is mainly for you. However, if you are A&B cohort and you were absent the day we did the Magnetism Lab in class, you guys will be using these as your instructions and following the instructions for DLI as well. So DLI, today in class, we're going to be completing the Magnetism Lab. Your learning target for this lab is I can describe the magnetic field patterns of various magnets. So we're going to see single magnets, and then we're also going to see some bar magnets arranged in different patterns, like attracting or repelling, and kind of examining what those field lines look like. You guys will see this same kind of thing in one of our Amplify assignments this week using the simulation. So it's kind of fun to see this happen in real life. Basically, just as a rundown, what we did in class is we laid out a lunch tray, and on the lunch tray we threw some paper towels down, or some paper, and then we put a bar magnet on our lunch tray. And then over the bar magnet, we have a piece of transparency paper. And mainly that transparency paper just allows us to still see the magnet, but prevents any of the iron filings that we're going to use to actually touch the magnet because they're a real pain in the butt to get off. So we laid that transparency paper down, and then we sprinkled iron filings all over the top of that magnet. The great thing about this is if you guys have ever played with one of those little magnet games where you can kind of make the guy have a mustache, those little iron filings are the same thing you see in that bag, and they arrange themselves based on that magnetic field, which is that invisible space around a magnet. And they kind of arrange themselves like little magnets themselves. So each of those little iron filings has a north pole and a south pole. And you guys will kind of see how they arrange themselves and what pattern that looks like, so we can see what an actual magnetic field appears to be, even though it is invisible. Okay, for your guys' lab today, you have a couple different options. Obviously, you guys can't do the lab at home, but you guys will be looking at images that I've linked to each page, and even a video to show you guys kind of what the results of this lab looks like. You guys will be drawing these results, and you have one of three options with your sketches. You guys can either draw them directly in this PowerPoint. So if you look at the last 4 slides of it, you guys will see these little images where you can go up here, use the draw feature to draw what those magnetic fields look like. Again, that might be kind of difficult if you're not using a mouse or whatever the case, but that's up to you guys to kind of try that. Or you guys can take a picture of your sketches, do them on a piece of paper at home, take a picture, and then copy and paste those sketches in place of these. So you guys can click on these images and get rid of them and add your own image in of your sketch that you did at home. Okay, so there's 4, one for each of the 4 parts we're doing today, and I'm going to talk about this fourth part here in a second. Or your final option is to draw them on one piece of paper, take a picture of that one piece of paper, and then upload that to Padlet. So that might be your easiest option, but it's up to you, whatever works best for you guys. So either take one picture, throw all 3 of your sketches on one page, take a picture of it, post it to Padlet, or take 3 individual pictures of your different parts and then copy and paste them into the last slides on your data sheet, or again, use your draw feature to draw on those. Okay, so part 1 is the magnetic field of a single bar magnet. So what you guys will do for this is right-click this little link right here and click Open Link. It might take a second to load, but what you guys will see is the image that we did in class showing that bar magnet with all the iron filings. You can see how they arrange themselves really neatly. So when you guys are doing this sketch, you shouldn't just scribble. If you guys are scribbling a sketch, I'm not going to accept it because these iron filings are arranged in a really distinct pattern. Okay, so I should be able to see that pattern from your guys' sketches. So make sure you do a neat job sketching this. Okay, then once you've sketched it again, either on your piece of paper at home or in slide number 9 here with your draw feature, you guys can move on to part 2. Again, same concept. You guys have an image right down here on this link. Right-click it, open link. Take a look at that image. You guys are looking at the magnetic fields if we were to put 2 bar magnets end to end, north to south pole. So we're arranging them like this, where we have the north pole attracting to the south pole of another bar magnet. So show me what that magnetic field would look like between those 2 interacting, attracting magnets. Okay, part 3, you're just flipping one of those bar magnets, and so now we have 2 repelling ends coming together. Again, your setup looks like this, so north to north. And your image is once again linked in the bottom right-hand corner of your slide. Open that link to see the image. And lastly, you guys have this part. So what we do in class is take a little compass, and you guys, again, kind of saw this, or will see this depending on what order you're doing your assignments this week in the simulation activity on one, where you guys go into Amplify, you use the simulation, and then you drag a little compass to kind of see how those magnetic field lines look. So all I want you guys to do for this one is just watch this video. Okay, I'm not going to have you guys draw that image because as it turns out, that image will be exactly the same as this image on part 1. Okay, you're just looking at a single bar magnet. Those magnetic field lines that you draw using the compass in the video are the same as what you guys would observe in this picture. Okay, so I want you guys to disregard this very last slide tracing. So you really only have 3 sketches to do. Don't do sketch on part 4. Okay, with that being said, you guys have some questions to answer. So remember that anytime you see this little question mark in the upper right-hand corner, there's something for you to fill out there. So question number 1, a magnetic field is strongest where it has the most lines of force. Where is the field strongest around the magnet? So refer back to this picture here, or the sketch that you drew. Okay, basically where a magnet is the strongest is going to be where it attracts the most metallic items. So if we're talking about iron filings, where on that magnet are there the most iron filings? That's going to indicate where the magnet is the strongest. Okay, so take a look at that and tell me where on that magnet you think it might be the strongest because there's more iron filings congregating. Okay, question 2, do any of the lines of force sketched in figures, in this case 1, 2, or 3, cross each other or intersect? So do you think any of those lines would intersect? Again, kind of pay attention to the compass video as well. That'll show you guys an answer if you're still unsure. Okay, number 3, how do the sketches of figure 1 and figure 4 compare? Like I just said, those 2 sketches should be pretty close to identical. Okay, and number 5, a single bar magnet has 5 paper clips hanging from the end. So if this pencil were my bar magnet, I have 5 paper clips hanging off the end of that. Okay, anytime we use a magnet to attract something, we make temporary magnets, or basically little mini magnets, out of that object. So those paper clips that are attracted to the end of our bar magnet become little mini magnets of their own, and that's how they're able to attract more and more paper clips down the line until they're just not very strong anymore and we can't get any more to stick. With that being said, because they are temporary magnets, little mini magnets, they have a north pole and a south pole just like a normal bar magnet. So if the paper clips are now magnetized, they also now have a north and a south pole. So if we're looking at the very first paper clip touching that bar magnet, what would that top part be? Would it be the north or the south pole? That's your first little A here. What pole of the paper clip would be touching the north end of the magnet? So if this is the north end of my bar magnet and this is my first paper clip, that part that's making contact with the bar magnet is at a north or a south pole. Okay, and then finally, the very last paper clip that's hanging off the end, it's not touching anything else, it's just free hanging in the air, is at a north or a south pole. If it helps you guys draw a little image to see, all right, if this is my north end, then what's going to be touching it, and so on and so forth down the line of paper clips. Your final question to answer is here. You guys are going to be doing a little matching. So on the left-hand column, you have a couple different images showing us different orientations or layouts of bar magnets, similar to what you guys just did. And then on the right-hand corner, or right-hand side, you guys have 4 images that show us magnetic field lines. I know the yellow is kind of hard to see. I wish that was something that I could have changed the color of. But if you need to, you guys can just go down to the bottom right-hand corner and zoom in on that image a little bit just to see those better. Obviously, you can kind of tell which arrangement. This one wouldn't probably match to this one because the bar magnets are laid down differently. So we could obviously tell that's not going to be an answer. But like something like this where we have, all right, this could be this could be this, or this could be this, you guys have to then look at the magnetic field lines to be like, all right, are these 2 magnets attracting or repelling, and which matches to which? Okay, you guys will use the draw feature for this. So you'll go up here to tab, draw feature, you'll choose a pen, and you guys will just write A, B, C, or D under 5, 6, 7, 8, and 9, okay? One of A, B, C, or D will be used twice. So obviously there's only 4 magnetic field line images, but 5 questions for you to match. Okay, so one of these will be used twice. So A, B, C, or D will be used twice over here. Okay, so again, you guys can just write the answer underneath it. Again, those are probably not the correct answers. All right, once you guys are done with that, make sure you guys click on cursor. You guys will either have your drawn images here, your uploaded images images here, or you will have your images uploaded into Padlet. Either way, when you guys finish up, make sure you turn it in. You do need those images to get credit for this lab, so either in Padlet or in this PowerPoint. Okay, those are your two options. If you guys have any questions, let me know. When you're done, turn it in, and I hope you're all having a great day. Thanks.